Dear student, in this lecture we are going to cover one of the very important topic of physics known as Compton effect. Compton effect is an experimental observation of particle nature of light. Compton effect is just like a photoelectric effect. It is just like a photoelectric effect. Dear student, in photoelectric effect, a photon or a light is basically photon or a light. Sorry, let me say light is basically in photoelectric effect. Light is incidented on the surface of a metal, and on the incidence of a light on a surface of a metal result into ejection of electrons from the surface of a metal. Whereas in case of Compton effect, uh, X-rays are basically X-rays, which are the type of electromagnetic radiations. They are basically incidented on the surface of a graphite, which is non-metal, and on the incidence of X-rays on the surface of graphite result into ejection of electron plus photons. So this is a difference between a photoelectric effect and Compton effect. In photoelectric effect, photon basically transfer its all energy to electrons, okay? Whereas in Compton effect, X-rays, which are electromagnetic radiations, they have highly energetic photons, but the energy of the photons of X-rays result into ejections of electrons, and as well as deflection of photons from the deflection of the incident photons, which are basically a part of the X-rays radiations. So basically, in photoelectric effect, total energy and momentum are transferred, whereas Compton effect, there will only change in a frequency, and as well as there will be a shift in a wavelength of incident photons, which are basically a part of X-rays. So, different in order to understand briefly the Compton effect, you need to understand some information, or you need to know history about the dual nature of light. Dear student, initially it was not known that light has a wave or a particle nature. In 1801, it was Young who performed Young double slit experiment. And in Young double slit experiment, Young basically incidented a light on the slits, and he observed the different types of physical phenomena such as reflection, diffraction. There were two types of diffraction which Young observed. These diffractions were basically constructive diffractions, or and as well as destructive diffraction, or constructive interference or destructive interference. So he also observed interference, and he also observed another physical phenomenon, which is a property of a light, which is known as rarefaction. So on the basis of reflection, interference, diffraction, and rarefaction, Young said that light, which is electromagnetic radiations, have a wave nature. The wave nature of light remain, the particle nature of light remain unknown up to 1870, 1887, in which Heinrich Hertz performed uh, an experiment which is known as photoelectric effect. And in photoelectric effect experiment, Heinrich Hertz basically incidented the light on the surface of a metal, and he observed the flow of electrons which basically cause a current. So basically light, which is a wave, according to Young double slit experiment, causes the ejection of electron, and that ejection of electron result into a generation of a current. So the explanation of this phenomenon was unknown up to 100 years, and it was in 1905 where Einstein Einstein explained the phenomenon of photoelectric effect. And according to Einstein, Einstein said that light consists of particles, and these particles are known as photons. Photons are present in a bunch of packets, and these packets are known as quanta. So whenever the quanta of light fall on the surface of a metal, they result into ejection of electron, which causes the electric current. So Einstein in 1905 explained the Hertz experiment of photoelectric effect on the basis of that he concluded that light has a dual nature. Light is behave like a wave, and it's also behave like a particle. So now, after the confirmation of dual nature of light, it was uh, it was Arthur Holly Compton who performed another experiment, and he basically explained the particle nature of electromagnetic waves by incidenting X-rays on the surface of graphite. So to let us explain photoelectric effect and Compton effect with a schematic diagram. In photoelectric effect, basically Heinrich Hertz took a metal, and as you know that metal consists of electrons, and these electrons resides on the surface of metal. These electrons are loosely bounded to the atom or to a nucleus of atoms present in a metal. So this is Hertz experiment, and in this experiment, Hertz basically incidented a light on the surface of a metal. And since you know that light is consist of photons, and these photons have energy, and energy of photon is equal to h into nu. And similarly, electron resides on the surface of metal. They have a specific binding energy which is basically known as threshold energy. And according to in order to eject electron from the surface of a metal, it is very important that energy of the incident photon must be greater than the binding energy of the or the threshold energy of the electron of metal present on the surface of a metal. So when the energy of electron, Hertz observed that when energy or higher energy of photon incidented on the surface of metal, if the energy of the photon is greater than the binding energy of the electron, Heinrich Hertz observed that electron ejected from the surface of a metal. The ejected electrons are basically known as photoelectron. So basically this confirms a particle nature of a wave, particle nature of a light, sorry, because light is basically incidented on the surface of metal. Whereas interestingly, in Compton effect, Compton basically took a graphite, and this graphite it was incidented by highly energetic it was incidented by highly energetic radiations, and these radiations are known as X-rays. So X-rays, basically Compton was interested to understand the particle nature of all types of or different types of electromagnetic radiation. That was the reason. That's why he incidented X-rays on the surface of graphite. And he observed that when X-rays, which were basically highly energetic electromagnetic radiations, these X-rays caused the ejection or reflection of electrons, and along with that he observed that the incident beam of X-rays, which is basically highly energetic, it also basically it is also reflected, or the photon of X-rays were reflected. So basically he observed that whenever a highly energetic beam of X-rays or highly energetic electromagnetic radiations basically fall on a material, they basically transfer some of their energy, which causes the ejection of electrons, and whereas the remaining energy will be basically will remain, and it will be just will be reflected in a form of a radiation with a lower energy than the incident radiation, or than the incident energy of the incident X-rays. So some of the energy was basically some of the energy some some of energy is transferred energy is transferred in Compton effect, whereas in photoelectric effect complete energy and as well as energy plus momentum is transferred, and which cause the ejection of electron. So now, dear student, now we will briefly discuss that how that what will be basically a change in or a shift in a wavelength in a Compton effect when an X-rays are basically or photon of X-rays are incident on the graphite metal. And so basically both these phenomenons, Compton effect and as well as photoelectric effect, they explain the particle nature of light. But in photoelectric effect, total energy and momentum are transferred, whereas in Compton effect, some amount of energy is transferred in ejection radar, and the rest amount of energy of incident light is basically released. So now we will discuss in Compton effect that how much energy is basically what is basically a remaining energy, or what is a shift of a wavelength, which is basically what is a shift in a wavelength which causes the Compton effects. So there is a lot of mathematical derivation in Compton effect, so we will comprehensively explain step by step the shift in a wavelength of a X-rays when it is incident on the graphite non-metal. Basically, students, please keep in mind that this easily explain the dual nature of a light. Or it easily explain the particle nature of a light. So now let us discuss the Compton shift of a wavelength when X-rays is incident on the surface of a graphite. Dear student, consider that we have a graphite atom, so we cannot basically represent graphite atoms. So basically in Compton effect, electrons are basically ejected from graphite when X-rays are incident. So suppose that this is an electron, okay, and in photoelectric effect X-rays, suppose that this is a representation of X-rays. Highly energetic X-rays are incidented on the surface of graphite. And when X-rays are incidented on the surface of graphite, X-rays are basically electromagnetic radiations. These X-rays will basically cause an these X-rays will basically cause an these X-rays will basically cause a scattering of electrons. So electron will be scattered like this, and similarly they will basically also scattered a photon. So dear student, please keep in mind that whenever X-rays are incident, so the frequency of X-rays will basically decrease when it is incidented on the surface of a graphite. So the because the and the sum of the energy will be basically transferred to in the scattering of electrons, and and the remaining energy will be less, and it will be basically scattering electron. It will be basically transferred, or it will be basically scattered in a form of X-rays with higher with lesser frequency and longer wavelength. So it is a scattering photon. So basically, in Compton effect, X-rays are incidented. X-rays, highly energetic X-rays, are incidented on the surface of a graphite, which causes the ejection of electron from the surface of a graphite. Ejection of electron from the surface of from graphite, which is known as a scattered electron. And similarly, along with that, there will basically also release or scattered a photon, which is basically have an energy and frequency lesser than the incident beam of X-rays. Since you know that the X-rays are basically photons, these are electromagnetic radiation, they are highly energetic photons. So initial energy of X-rays photon will be EP, which represent an energy of photon. It will be h into nu. And similarly, as you know that according to wave particle duality, or according to de Broglie, particle behave like a wave, and relationship between the wave nature and particle nature is lambda is equal to h over p. So p will be equal to h p will be equal to p will be equal to h divided by lambda. And as you know that p is equal to h divided by lambda, lambda, suppose this is equation number 1, lambda v is equal to velocity is equal to nu into lambda. So lambda will be equal to v divided by nu. So equation number 1 will become p is equal to h, p will be equal to h nu divided by v, and velocity of photon is equal to c. So p will be equal to h nu divided by c. So we can write the value of momentum as the momentum of photon p will be equal to h nu divided by c. So now student, in Compton effect, as you know that electrons are X-rays which are highly energetic or incident on the electron which are present on the surface of a graphite. So these electrons are usually they are moving with very small speeds. So basically they are considered as at a rest. So at a rest, the energy of electron at a rest is known as rest mass energy, and it is equal to E is equal to m naught into c square. And whereas the momentum of proton, since you know that if body is not moving, so then if it is not moving, then the momentum of that body is equal to 0. So at a rest, the momentum of electron will also be 0. So now when the X-rays are incident, when X-rays are incident on the electron, these X-rays basically cause the scattering of photon. So the scattered photon will have different energy than the incident energy of X-rays photon. So we can represent the energy of scattered photon as energy of scattered photon will be E, energy of scattered photon by prime, and suppose that it is h into nu dash, because the frequency of scattered photon will be lesser. Frequency nu dash of scattered photon will be lesser than the frequency of incident photon of X-rays. Similarly, the momentum of scattered photon will be momentum of scattered photon will be represented by a p prime, and it will be equal to h nu dash divided by c. Okay, so now similarly, dear student, energy of scattered electrons, since the X-rays are causing the scattering of electrons also, so the energy of scattered electron will be E is equal to, it will be E is equal to mc square. And similarly, momentum of scattered electron P E dash, which will be different than the initial momentum of electron, which is basically zero, which is at rest. So it will be, as you know, that momentum is equal to P is equal to m into v. So a momentum of scattered electron will be m into v. Since you know that the momentum is a vector quantity, okay, so basically this is the momentum of a scattered photon is a vector quantity, so it will be resolved into x component and y component. So the momentum of a scattered photon will be p dash x along the x-axis, and similarly momentum of a scattered photon along the y-axis will be it will be p dash y. Similarly, the student, momentum of a photon is also a vector. Momentum of electron, scattered electron, is also a vector quantity, and it will also can be resolved in x and y component. So x component of momentum of electron can be represented as p dash momentum of electron along the x-axis, and similarly along the y-axis the momentum of electron can be represented as p dash momentum of electron along the y-axis. So now momentum along the x-axis, as you know that along the x-axis it is momentum along the x-axis for a photon is p dash x. It is basically p represented as p dash cos of phi for x-axis. Angle of phi is as the angle of photon, so it will be, as you know that momentum p dash is equal to h nu. So for p dash it will be h nu divided by c into cos of phi. This is a momentum of a photon along an x-axis. So now momentum of a photon along a y-axis, as you know that p dash y can be written as p dash sine of phi, which is an angle of a momentum, and as you know that momentum p dash is equal to h nu divided by c and sine of phi. So momentum along a y-axis will be h nu sorry, nu prime, because p prime momentum is p prime, so it will be h nu prime divided by c into sine of phi. So similarly, momentum of we can write momentum of electron along x-axis as p e x. It could be written as p e prime x is basically can be represented by cos of theta. So momentum of an x-axis will be equal to PE is basically equal to m into v, and it can be written as mv into cos of theta. Okay. Similarly, momentum of electron along a y-axis can be written as you know that Pey is basically P prime into y is for sine of theta. So we can write mv into sine of theta for momentum of electron along a y-axis. Okay. So these are the key associated parameter when a highly energetic X-rays are incident on electron. They basically cause a scattering of electron and as well as scattering of photon. So the scattered photon have an energy of scattered photon is basically h into nu dash, whereas the momentum of a scattered photon basically is a vector quantity, so it will have a resolved component along the x-axis and as well as y-axis. So momentum along the x-axis will be p dash cos of phi, which is h nu divided by c cos of phi, and momentum along the y-axis for photon will be h nu dash divided by c into sine of phi. Similarly, momentum of electron along the x-axis will be mv cos of theta, and similarly momentum along the y-axis will be equal to mv into sine of theta. So basically now write all these in a form of an equations. Write the momentum and energy of initial and as well as final scattered. So initially, the initial momentum of a photon, which is basically momentum of X-rays photon, it is equal to h into nu. Whereas a final energy of a photons, which is basically represented by EP prime, and it will be equal to h into nu dash. This is for energy for photon. Similarly, dear student, the momentum of a photon, initial momentum of photon, as you know that photons are P is equal to h into nu divided by c. This is an initial momentum of photon, okay? And when photons are incidented on electron, they cause they basically are scattered, and these photons have x and the momentum of photons have x and y component. So basically the x component of photons will be basically p dash x of photon. Momentum of that x component of photon will be equal to h nu dash divided by c into cos of phi. And similarly, momentum of a y component of photon p dash y, it is basically equal to p dash into sine of phi, which is equal to h nu dash divided by c into sine of phi. So this is representation of a momentum of photons along the x-axis, initial and final momentum of photons along x-axis, photons momentum along x-axis. This is the of photons, energy of photons. Now now uh, now write equation for the uh, energy and as well as momentum of electron. Since you know that initially electron is at rest, so initial energy of electron is basically rest mass energy, and it is equal to E naught mc square, whereas the momentum of electron and final energy of electron, let's write final energy of electron. Final energy of electron E will be equal to mc square. which m is basically it is a relative mass, and m naught is basically it is a rest mass of an electrons. So this is energy for electrons. Okay, is equation for energy of electrons. Energy of electrons. So now, dear student, let us write an equation for momentum of electrons. So as you know that initially momentum of electron are at rest. So initially the momentum, when a body is at rest, then its momentum at rest is equal to 0. Now the electrons are, when the X-rays are incident electrons, the electrons are scattered. So the electrons, scattered electrons have X and Y component. So the momentum of scattered electron along the x-axis will be p dash x, and it will be equal to m v cos of theta. So this is the momentum of electron along the x-axis, and the momentum of electron along y-axis is it is equal to m v into sine of theta. So these are basically equations for a Compton effect. This is a momentum of electrons. These are basic equations for the energy and momentum of electron whenever a beam of X-rays or a beam of photon is incident on electrons. So now, dear student, according to law of conservation of energy and law of conservation of momentum, the total amount of energy will remain conserved whenever photons with a specific energy and as well as a momentum incidented on electrons, then the electrons will be deflected, or photons, they are also being scattered or deflected, but the initial energy and momentum of photons will be equal to the initial energy and momentum of scattered photon and as well as electron. So basically in Compton effect, there will be an elastic collision. Basically a total energy of incident X-rays will be transferred, or will remain same, and it will be transferred in a form of scattering of electron and as well as scattering of photon. So now applying a law of conservation of energy and as well as law of conservation of momentum to calculate the Compton shift in a wavelength of an incident photon of X-rays in Compton effect. So distant shift or a change in a wavelength of an incident photon on a graphite is in a Compton effect is basically calculated on the basis of applying a law of conservation of energy and as well as law of conservation of momentum. So now applying a law of conservation of energy, law of conservation of energy. Law of conservation of energy state that the initial energy of law of conservation of energy, initial energy of photon, initial energy of photon and electron before incidenting is equal to the final amount of electron, energy of electron and as well as photon when they are scattered upon the application of energy of an incident photon. So this means that initial energy of photon, which is basically energy of photon plus the initial energy of electron, which is basically an electron of a graphite atom, is equal to the final energy of photon, which is a scattered photon whenever a photon is incident on graphite plus energy of a scattered electrons. It is electron which is basically scattered when an highly energetic beam of X-rays is incident on the graphite. So this means that total amount of energy remain conserved. As you know that initial energy of photon is basically it is equal to E is equal to H into nu, and whereas since electron is at rest, so initial energy of electron will be a rest mass energy, and it is equal to E is equal to m naught into C. The scattered energy of photon will be nu energy, and it is, as you know that from equation, it is E is equal to H into nu. So for scattered photon it will be E H nu prime plus energy of the scattered electron. It is a relative energy, and it will be equal to m into C square. So now let's shift this h nu on left side, and we can see that h nu minus h nu dash and mc square shift it to this right side, and we can write this equation as mc square minus m naught into c square. Now taking h common in this equation, h into nu minus nu prime is equal to mc square minus m naught into c square. So say this as equation number 1. Write this as equation number 1. Let us use law of conservation of momentum. Law of conservation of momentum state that law of conservation of momentum in Compton effect state that initial momentum of photon initial momentum of photon plus electron is equal to final momentum of proton and as well as final momentum of photon and as well as scattered electron. Since you know that momentum is a vector quantity, so it will have a x component and as well as y component. So the electrons which are incident on the graphite photon which are incident on a graphite, they eject electrons. So the ejected electron will have x component, and as well as the ejected electron will have y component. Similarly, ejected photons, they will also have x component, and as well as they will have y component. So now, dear student, according to law of conservation of momentum, the momentum of photon along x-axis will be initial momentum of photon plus initial momentum of electron. It will be equal to momentum of photon along x-axis plus momentum of an electron along the x-axis. So this is basically a momentum of photons and electron along the x-axis. So as you know that momentum of photon P is basically it is equal to h nu divided by c, and initially the electron is at rest. So momentum of electron at rest is equal to 0, and momentum of photon along x-axis, this is x-axis, the momentum of photon along x-axis will be equal to pre prime into cos of phi. And similarly, momentum of electron along x-axis, it will be equal to pe prime into cos of theta. So since you know that, dear student, momentum of electron pe prime, it is equal to m into v. Momentum is basically equal to m into v. So the momentum along the x-axis will be p p dash e cos of theta along x-axis will be m into v into cos of theta. So, and similarly, momentum of photon, as you know that momentum of photon along x-axis p dash cos of phi, as you know that momentum is h nu, so for p prime it will be h nu divided by c into cos of phi. So now putting these values in equation, we get h nu divided by c is equal to h nu prime divided by c into cos of phi plus mv into cos of theta. So now multiplying this equation with a c, or with the speed of light. So we basically get h nu divided by we get, after multiplication of c, we get h nu h h nu is equal to h nu prime cos of phi plus m plus mvc cos of theta. So now shifting MVC on the left side and HV on the right side. So we get equation for momentum along the x-axis as MVC cos of theta is equal to H nu minus H nu into cos of phi. So let's say this is equation number, let's say this is equation number 2. This student, now applying a law of conservation of momentum along a y-axis. As you know that initial momentum along the y-axis of electron and photon before the incidence must be equal to a final momentum of electron and scattered photon. Okay, so we can write this as initial momentum of electron before incidence, initial momentum of electron plus initial momentum of photons before incidence is equal to final momentum of photon which is scattered plus along the y-axis plus final momentum of electrons which are basically scattered along the y-axis. Rearrangement, as you know that electrons are present at rest, so initial momentum of electron before incidence, they are at rest, so it will be 0, whereas initial momentum of electron along the initial momentum of photon along y-axis is also 0, because the beam of the beam of x-rays are incidenting along a specific x-axis. So now the final momentum of photon after the incidence, it will be along a y-axis, it will be h nu prime divided by c into sine of phi for y-axis plus momentum of electron, as you know that it is mv into sine of theta. So now we can write this equation as mv sine of theta is equal to h nu prime divided by c into sine of phi. So now we can multiply c with this equation and we can get a new equation as MVC into sine of theta is equal to H nu prime into sine of phi. So let's say that this equation is equation number 3. Now students, since we know that equation 2, we can write equation 2 as MVC cos of theta is equal to h nu minus h nu prime cos of phi. So this is equation number 2. So now squaring equation number 2, so we basically get, by squaring this equation number 2, squaring, we basically get a new equation m square v square c square cos square of theta is equal to h square nu square plus h square nu prime square cos square of phi minus 2 h square nu prime into cos of phi. So we can write this as equation number 2, 2 steric. Let us write this as equation number 2 steric. Student, please keep in mind that we write this because of the formula a minus b whole square, which is equal to a square plus b square minus 2ab. So we have used this formula of trigonometry for squaring the equation number 2. Now, dear student, since we know that equation number 3 is mv c sine of theta is equal to h nu prime sine of phi. This is equation number 3. Now, dear student, squaring this equation number 3. Squaring equation number 3, we get new equation as m square v square c square sine of theta is equal to h square nu square sine square of phi, and suppose that this is equation number 3 steric. So now, adding equation 2 steric with 3 steric, so we get, adding these equations, m square v square c square cos square of theta plus m square, this is the right side of adding these two equations, m square v square c square sine of square of theta is equal to h square nu square plus h square nu prime square cos square of phi minus 2h square nu prime cos of phi plus h square nu prime square sine square of phi. So now, as you know that, dear student, according to trigonometry, let's take common m square v square c square. On the left side, we can get cos square of theta plus sine square of theta is equal to h square nu square plus h square nu prime square cos square of phi minus 2h square nu prime cos of phi plus h square nu prime square sine square of phi. So you know that, dear student, sine square of theta, uh, cos square of theta plus sine square of theta is equal to 1. Then the equation above become m square v square c square is equal to h square nu square plus h square nu prime square cos square of phi minus 2h square nu prime cos of phi plus h square nu prime square sine square of phi. So we can simplify this equation as m square v square c square is equal to h square nu square plus h square nu prime square into cos square of phi plus sine square of phi minus 2h square nu prime cos of phi. So again we know that cos square of phi plus sine square of phi is equal to 1. Then above equation will become m square v square c square is equal to h square nu square plus h square nu prime square minus 2 h square nu prime cos of phi. And suppose that this is equation number 4. Now students, since we know that equation for energy, equation 1, since we know that equation 1 for energy, equation 1 for energy is h into nu. Let me rewrite. Equation number 1 for energy is h nu minus nu dash is equal to mc square minus m naught c square. This is equation number 1 which we have previously calculated. So let us shift m naught c square here. So we will get mc square is equal to h nu into nu prime plus m naught into c square. So now students, let us squaring this equation. We basically, by squaring, we basically get m square c4 is equal to h nu dash whole square plus sorry, not whole square. We get basically h nu plus h nu minus nu dash plus m naught c whole square of this. Okay, we basically, after squaring this equation, we basically get m square c4 is equal to h square nu minus nu dash whole square plus m naught square c4 plus 2h nu minus nu dash m naught c square. So then we basically get this equation m square c4 is equal to h square nu square plus h square nu dash square minus 2h minus 2h square nu dash plus m naught square c4 plus 2h nu minus nu dash m naught c square. So suppose that this is equation number 5. So now the student subtract equation 4 from equation 5. So we will get m square c4 minus m square v square c square is equal to h square nu square plus h square nu prime square minus 2 h square nu prime plus m naught square c4 plus 2 h nu minus nu prime m naught c square minus h square nu square minus h square nu prime square plus 2 h square nu prime cos of phi. So we can clearly see that h square nu square will be cancelled with h square nu square. Similarly, h square nu prime square will be cancelled with minus h square nu prime square. So after subtraction, this equation will become m square c4 minus m square v square c square is equal to minus 2 h square nu prime plus m naught square c4 plus 2h nu minus nu dash m naught c square plus 2 h square nu dash cos of phi. So now students, let us take on left side take m square c4 common. So by taking m square c4 common, basically we get 1 minus v square divided by c square, which is equal to minus 2 h square nu dash plus m naught square c4 plus 2 h nu minus nu prime m naught c square plus 2h square nu prime cos of phi. And we say to this as equation number 6. So student, according to theory of relativity, the relativistic mass, the formula for relativistic mass is m is equal to m naught divided by under root 1 minus v square divided by c square, which means that if we square this equation, m square is equal to m naught square into 1 minus v square divided by c square. So if we include this value in equation number 6, then equation number 6 will become m naught square C4 is equal to minus 2h square nu dash 1 minus cos of phi plus m naught square C4 plus 2h nu minus nu prime into m naught c square. So the m naught square C4 will cancel m naught square C4, which means that this equation will then become 2h square nu prime into 1 minus cos of phi is equal to 2h nu minus nu prime m naught c square. So this 2h will cancel with 2h on the left side. So then equation will become h nu prime 1 minus cos of phi is equal to nu minus nu prime into m naught c square. So now dividing both sides by mu prime and m naught c square. So we will get equation h divided by m naught c square into 1 minus cos of phi is equal to nu minus nu prime divided by nu prime into nu. So we say to this as equation number 7. So students, since equation number 7 is h divided by m naught c square into 1 minus cos of phi is equal to nu minus nu prime divided by nu prime into nu, and as we know that v velocity is equal to nu into lambda. So velocity here is a velocity for photon, and it is usually around, it is speed equal to speed of light. So c will be equal to nu into lambda, which means that lambda is equal to c divided by nu. And the student, as you know that Compton shift in wavelength on change in a wavelength is equal to nu, lambda is equal to lambda prime minus lambda. And as you know that shift in wavelength is equal to, as you know that lambda is equal to c by nu, so lambda prime will be equal to c divided by nu prime minus lambda is equal to c by nu, so it will be equal to lambda will be equal to c by nu, and then by taking common c we get c into 1 by nu prime minus 1 by nu. Okay, like this. And basically mean that shift in a wavelength is equal to c into 1 nu prime divided by 1 over nu. So dividing dividing C on both sides, change in wavelength divided by C is equal to 1 over nu prime minus 1 over nu. So now when we take LCM, so we will basically get this equation as nu minus nu prime divided by nu into nu dash. So which means that lambda prime minus lambda divided by C is equal to nu minus nu prime divided by nu into nu prime. So suppose that this is equation number 8. So this is now putting equation 8 in equation 7. Then when we put equation 8 in equation 7, we basically get a new equation which is lambda prime minus lambda divided by C is equal to H divided by m naught C square into 1 minus cos of theta. So this C square will be cancelled with C, and we will get new equation as lambda prime minus lambda is equal to H divided by m naught C into 1 minus cos of theta. As you know that lambda minus lambda prime minus lambda is a Compton shift in a wavelength. So we can write this equation as Compton shift in a wavelength is equal to H divided by m naught C into 1 minus cos of theta. So this is equation for a Compton shift in a wavelength. So now the interaction of basically the shift in a wavelength may take place with a different angle, or interaction of a photon with an electron could take place with a different angle, like theta could be 0 degree, it could be 90 degree, and it could be 180 degree. So on the basis of that, the interaction of photon with electron and the scattering along the different angle, so that can be easily calculated by the equation which is derived from a Compton shift in a wavelength, which is H divided by m naught C into 1 minus cos of theta. So this is very important derivation. Basically this equation tells us the particle nature of an electromagnetic express, or a particle nature of a wave. So this is all about Compton effect. The student, Compton effects explain the interaction of a light with a matter, and it explain a particle nature of an electromagnetic radiations, or electromagnetic light or rays. So this is all about Compton effect. So thank you for watching.